Hello, everyone. Welcome to Decon Deception. What labs think is safe isn't, right? So I want to just extend a thank you for everybody showing up. Really appreciate it. My name is Pat Davis. I will be your host. I am the CEO and Sales Director of Safe-Decon, and I have partnered with the guest speaker to help bring a very important message out really, hopefully leave you guys with some food for thought. So every day, labs across the country, they run autoclaves, they seal waste in bags, they assume it's sterile, right? But what if that assumption is wrong, right? So I've personally traveled to universities, symposiums, and various government events over the past 2 years with today's speaker. And I can tell you, there's no one more qualified to speak on what's really happening behind the scenes, all right, with these decontamination protocols. So today we're going to talk about some risks, some overlooked failures, the truth behind, the practices that many think are working, but simply aren't. So our guest speaker that I'll be bringing that'll be coming to the stage here, his name is Bob Dudley. He certainly is the CEO and founder. He's right at 20 years biomedical technician experience. He's been inside the labs. He's got the experience. So, we're not talking speculation here. We're not or theory here. We're talking to somebody who's actually, been out in the field, seen it and done it. So without further ado, ladies and gentlemen, I want to welcome to the stage Mr. Bob Dudley.
Hi, everybody. This is Bob Dudley. For those that do know me, there are a few that do not. As Pat said, I've been a biomedical engineer and technician for about almost 2 decades. The scope of where I worked is I started out in hospitals, surgery centers, got wrangled into doing research institutions, started off at Torrey Pines and started working at places like Scripps and, places like that, and ended up worked my way up into the high containment BSL labs as well. And that is basically who I am in my experience. Today, I want to talk about the autoclave and how it works. One of the things that I noticed in all the years that I've been in literally everywhere is really the lack of knowledge of how the autoclave works, why it works. And with the lack of understanding comes a lot of mistakes. And on several occasions, those mistakes has gotten me exposed just by improper handling, wrong SOPs, lack of training, a lot of human errors. And what I found is that people just really don't know what an autoclave is or why it is. They just look at it as, hey, there's this magical box right here. You put everything inside, hit a button, and everything ends up coming out dead, sterilized, decontaminated. Life is good. What I'm going to show you today is that is not necessarily true. I'm going to explain a few things about autoclaves. I'm going to explain to you why they work, why we use high pressure steam. I want to explain just the thermodynamics involved. And I know that's going to sound real boring. Who wants to know about thermodynamics? But I'm going to simplify it so that it's very understandable, so that you understand what happens in the autoclave and why. And this is going to help you to better understand what you need to do to get the results that you're looking for. And this is generally what I do when I was out in the field. So with that, I want to take, like I said, the deep dive. We're going to walk through the testing data at the end that I've been doing. And by the end of this, my goal is simple. I just want you to walk away with a deeper, clearer understanding, one that will help you in your lab to not just be safe enough, but to be safe. And there is a difference between being safe and being safe enough. We all want to be safe. So with that, let's go ahead and get started. So Yep. And I want to take a deep dive into the autoclaves. And what I want to explain, the autoclave is one of the most critical components that you have, especially out of these high containment labs. If there's an accident inside the lab, you have your environmental, you have all your layers of safety, the environmental cabinet, you have the rooms, you have the hallway, all the negative pressure pulling everything in and out. When you get to this autoclave and you're trying to autoclave everything out, that's your last line of defense. That is between the back, the hot area, and then getting out into the public areas. And I know that there's protocols, but again, they did not work. On three separate occasions, I was exposed. Once I was quarantined twice. Once was with a antibiotic resistant TB, and I started coughing up blood several months later, and had to isolate me for 2 days, run the blood work, testing, and then of course, then I had to explain to my wife that I may have killed us both, and she didn't really know where I was working. So that went well. Slept on the couch for a couple days on that one, but ended up not having the TB. I had picked up another upper respiratory problem from another lab, and that was also in Asia that they were working on. So I was just sick for about 4 months with this one. Yeah, it was miserable, and it was very, very preventable. Uh, so a lot of what I've seen out in the field too is there's a lot of untrained people. People, like I said, they're just told to stick stuff in and then hit the button and everything will be fine. Life is good. It comes out the other end. We're fine. Since 2020, there are 276 lab leaks. Quite a few of them have been related to not having run proper sterilization at the end, improper loading, and it's just failed. And again, that's what happened to me on several occasions. So, I can attest to this in real time. And this is the ones that were reported. Out of the three, only one was really reported. So I know that there was two unreported. The one, they didn't have a choice with the TB. So again, today we're going to kind of go through it. So what I want to talk to you about is the autoclave. Conceptually, it's just, this thing is probably about as simple a machine as it gets. This is a pressure cooker. It does a couple extra special things, but the autoclave is just nothing more than a very highly specialized pressure cooker, just like you would have at home. And it is basic, simple concept. So, but let's go ahead and get started, and let's start talking about it. I want to talk about steam, why steam is used. I want to have a discussion about the steam saturation or the humidity. I'm going to discuss about the pressure and vacuum and the effects on steam and liquids. I'm going to talk about the different cycles, their purpose, and then I will explain the physics and the thermodynamics of those as well, and the importance of getting the right one and why. Then we're going to get into the testing that I did, the testing cycles, the different results, and we're going to show those. And at the end, we can have some discussions about my findings, questions you may have, opinions, and everything else. So, understanding steam. Steam is pretty much the hammer to heat the nail. Steam isn't what kills any spores or any pathogens. The steam is just more the hammer that drives the heat in to effectively denature proteins, to get them to break down and to effectively kill it. And with steam, what happens with it is steam will attack cool spots, and it pulls the heat in. So when you're first starting your cycle on your autoclave, what's generally happening is the steam comes in and it gets to the contents, and it tries to force its way into deeper content. So just like the Venturi system or a vacuum, they will run cool water, and then that's what pulls the steam out to pull the vacuum when you see a vacuum on it. Cold water is used. If you use hot water, steam is not attracted to the hot. So the hotter the water, the less likely the steam is going to attack or penetrate deep inside. Just like a hammer does to the nail, it drives in that heat inside. Another thing I want to talk about is the steam saturation or the humidity. Very similarly to just outside, steam is essentially just a gas, but it has a certain amount of humidity. I'll give you an example. If your autoclave is running correctly, you should be able to take a paper towel, put it in the autoclave, run it, and when it's completed, you should be able to pull that paper towel, and it should be dry. That's if it's running correctly. So steam saturation plays a very, very critical role. Too little, you do not get the penetration of the steam. Too much, and then what happens is it starts condensating when it hits the cooler areas, and it will form a barrier. It'll form a barrier so that heat cannot go deeper inside. And this will be explained a little bit later. And then with the testing results, we can go over that as well. But steam saturation plays a very, very, very critical role in the autoclaves and getting the proper penetration and heat penetration to the contents. And so that'll play a part in one of the biggest myths that I have found in probably about 15 to 20% of the facilities that I have worked in. They add liquids. They'll add 100 milliliters to 250 milliliters of water to a bag. They seal it up, and then they think that that's going to actually get them to kill. Today, I am going to bust that myth. It is, if you're using liquids in your bags, I'm about to blow your mind here with the testing results that I have coming up. I'm going to talk to you about the effects of pressure. You can see on the charts, and if you look at the chart to the left, this is pressure going up. So if you look at the chart, you'll see that as pressure goes up, so does the boiling point or the water saturation pressure. So if you are at sea level, your boiling point would be at 212 degrees. So if you're in Florida or some lower level area, your boiling point is going to be pretty close to 212. On the other side of it, just if you're in, let's say you're in Denver and you're mile high, because your atmospheric pressure is only like 9.5, your actual boiling point is going to be closer to about 190 degrees, I think it's 188 to 190 degrees. So that's where your boiling point. But as the pressure builds, and as especially those in labs that are cooking media, sterilizing media and liquids, you know that if you just boiled it, it would boil out at 212, but you've got to get it to that 250 to get it to sterilize it. Of course, we all know 15 psi, 15 minutes kills the spores, bacteria, everything else that's in it. So what they've done with the steam sterilizers, they put the steam under pressure. So you'll see that as the pressure rises and you get up to 15 psi, your boiling point on your water is at 251, so or 122. So you're right before the boiling point at that. So if you're adding liquid to a bag to sterilize that bag and produce steam, it's not producing it. That liquid is not boiling on the inside, and that's important to remember. And again, even if you run, let's say okay, fine, I'll run it hotter to get it to boil. I'll run it at 274 or 132. The boiling point at that point is 275 or 133. So you're still not going to boil at that point. But let's look at the other side of this. Let's look at the vacuum. And this is where this plays a very important role. You have, if you'll look at the chart and you're at atmospheric, you'll see that it bows down. Now, if you look at that 132 to 180, that 132, if you pull 25 inches of vacuum on your on your autoclave, your boiling point on your water is at 132. At 29 inches, if you have a really good autoclave and you're actually able to get down to that 29 inches, which is the vacuum of space, outer space, your boiling point is at 80 degrees Fahrenheit. I mean, that is really, really low. So with that knowledge, let's look at the cycles. And now that you can see, now that we explained that as pressure goes up, the boiling point goes up with it, and as the vacuum, as you drop it down and pull the vacuum. So let's take a look. When you have a gravity cycle, which a lot of people run, if you look at this top left one, you'll see that it has a sort of a preconditioning. You usually have a purge, and that's that little bit of a hump, and then it makes a steady, gradual climb upwards. So on the gravity cycle, it just is pretty much what it is. It just uses gravity to go up and down. So it adds the pressure to it until you get to sterilization. There's no preconditioning or anything to it. So if you have liquids and you're putting water in your bag or you're running any liquids, it takes it a lot longer to get it because, again, water is an insulator. It is a big insulator. It insulates. If you live on the coast, I lived on the coast in Florida. I live close to the ocean. I didn't get days in the mid to upper 90s. The water surrounding it was an insulator against the heat. And it's the same principle here. So with the gravity cycle, if you're just running regular trash, it's probably going to reach temperature quicker. Liquids are going to take a little bit longer. And again, just like on the stove, if you ran 100 milliliters of water in one pan and 250 milliliters in the other, and you put it under the same heat, the 250 milliliters is going to boil later on. So the more you have in it, the longer it takes to do it. So looking at the gravity cycle, so imagine you had liquid in there. When that valve opens up in the chamber and releases that pressure, if that pressure releases and the temperature is still the same at 250 and you take a drop under 2 psi, that water is going to just snap, just like a snap. It's going to instantly boil. It's going to come to a very, very hard boil. And for those that have autoclaved media and liquids, you've opened it up and all your liquid is gone out of your flasks and beakers. Where did it go? This is what happens with it. When your autoclave, when it releases pressure too quick and the temperature doesn't match the pressure, it's instantaneous boil, and it's literally an eruption and you lose everything. So if you're going to do a gravity with post vacuum, which usually if you're going to have post vacuum, you have the ability to do a pre-vac, it's the same thing. So you're going to essentially take your liquids and then you're going to bring the boiling point down to somewhere between 130 degrees to down to from 130 degrees down to 80 degrees. So yeah, but and then of course the third cycle, the liquid one, you'll see that post phase where the liquid cycle, it accounts for that. If your liquid cycle is correct, you're bleeding off pressure at a half a pound at the end of the sterilization time. At the end, you're bleeding it down a half a psi per minute. So that allows the water temperature to cool at a steady rate while the pressure drops. to match it to keep it from boiling out. If your autoclave liquid cycle is bleeding too fast, you're going to lose a lot of liquids, and I believe the rate should be about 5 to 10% loss on that phase. So if you're losing half of it, your autoclave's bleeding too quickly. And this comes to the pulse phase that you see, or the pre-vac. Now, you'll see that there's a lot of lines going between putting pressure in and bringing it down. Now, what this is preconditioning. Now, going back to your charts that I was explaining earlier, so what's happening is in the pre-vac is you are pushing that pressure in, and you're essentially just squeezing the contents, and then you're quickly releasing it, and that's why the lines go up and down so quickly. So you're pushing that in, and then you're pulling that vacuum. So what happens during the pre-vac is you're pushing that steam, it's attacking the cold spot, it condenses inside, sealing off deeper penetration. When it releases that pressure and it pulls a vacuum, any residual liquid that you're trying to get to penetrate inside is now, you're pulling vacuum, so now it's going to boil off. It's going to turn to steam at that point. And then when you see that second pulse go in, now it's able to drive in deeper. So you're squeezing, you're forcing, you're hitting that nail with the hammer of the steam, and you're driving it deeper into into your waste and materials that you're trying to get. So this goes on for 3 or 4 times before you get to the sterilization or the heat up phase. And what this allows you is a quicker, faster cycle, but you're getting deeper and a more consistent. And that's if your autoclave is working correctly. But let's go back to adding water. If you added water to any of these cycles, you're not getting that exchange of air. So if you're running a pre-vac cycle and you seal your bag, the likelihood that you're getting any exchange of air is not going to happen. You add that water, the steam's only going to penetrate so far, and then what generally happens is it's going to stop, and it's going to form that barrier against any deeper penetration. If you're just using like hard plastics, you want to put a liquid in, yeah, still better off not having it. But again, we'll go through a lot of this information when we get a little bit deeper into it. So what I want to do is I want to start getting into the testing that I did, because this is where the explanation of everything is going to be critical. I used my autoclave here. This is my V120 Scientific stairs. I also used the popper steam temperature strips, and what I wanted to see was whether steam was actually penetrating. So I used these steam strips in and out as well, and then I used a Bowie Dick test pack. And you'll see here, this was one that I kind of designed myself. And I had it on a hinge, and then I would tape them shut. But I had a place for the BI in here. And this was more to show how the penetration, and then I would just tape up the edge. For the harder ones, I would seal up the outer edge of these. But this was what I used. And then the BI would be placed in here. This would be shut. And this was for the later. In my testing, I made it more challenging to do. So I used the containment system. I used these bags, as you can see, the biological indicators, and then I also used the Safe-Decon containers that you see behind me. As far as the simulated waste loads, I used hard plastic boards, and then I used light trash, not heavy trash, but it was basically similar to PPE and things that you would normally throw in there. So as you can see here, that's a picture of what I was using. The test strips, the biological indicators. The biological indicators were the A-type indicators that were easily easily installed. So that was my test equipment. Here's the packs that I used, and I just used regular masking tape to seal them up. As you can see, where the BIs were placed and steam strips were placed on the inside of it pack and also on the outside. So let's take a look at these tests, because this was actually pretty interesting. On test cycle number one, what I was using a 250 cycle 121. There was no trash in it for the first three. I just had a piece of hard plastic that I taped the biological indicator and the steam strip, stuck it in the bag. Now, the first cycle, which was the Prevac 40, which was 4 pulses, 40-minute sterilization, and it had a 10-minute dry, I believe. Yep, 10-minute dry. Because there was really not much of a challenge, it went real well. Cycle 1 and 2, the bags burst eventually. The plastic bags, the pressure was going to get to them, and there really wasn't anything remarkable. You can see the steam strips. Steam did get to them, and that the biological indicators were negative. So those went well. I did run one liquid cycle just to kind of see what was going to happen with the liquid cycle. For the most part, you really don't want to run a liquid cycle. I mean, that is your very last choice, because you're not going to produce any steam, and the effectiveness of getting steam penetration is going to be very challenging. The liquids should be used strictly for liquids, and that should not be used for any waste at all. So I'm going to go ahead and we're going to move on here. Cycles 4 and 5 were just a continuation of the same. They were a Prevac 40, as you see on cycle 4. The bags burst on them. They got exposed. There really wasn't much of a challenge to it. But when you get to gravity 6, cycle 5, I mean, there's a gravity 40-minute cycle. You're going to see that the sealed one with water in it ended up having a positive BI. Now, that bag did not burst. It had 100 milliliters of hot water in the bag, as recommended by the CDC NIH folks. That was part of their SOP, was to put 100 milliliters or 250. And you'll see that the bag remained intact. It was sealed up, and it remained sealed. And now we got a positive BI. And you're going to start seeing a pattern here with these wet bags. And again, the physics of it make zero sense at all. You have to remember, more steam is bad. So in this case, less is more. So then on cycle 6, you're going to see things start going south very, very quickly on a lot of these cycles, both for the Prevac and the wet bag. On cycle 6, you're going to see that the Safe-Decon container, the sealed Safe-Decon container, passed, but the other two did not. If you look at the strips down to bottom, you'll see that steam actually got in there, but we have 2 positive BIs. Both of these bags remain sealed. Both of them. What I did is I stuck that pack that I showed you earlier in there. Then I did a sealed dry bag, and I taped up the dry bag, and I sealed up the wet bag to see what would happen. The steam got in there enough to change these strips to say, yes, we did achieve 250. The steam was on there, but it didn't achieve it long enough in order to get the kill on the BI. So again, you're going to start seeing this pattern here as I go along. So when we get to cycle number 7, now 6, I took the packs and I sealed up the edges, and so I did the same thing with 7, because I wanted to simulate a the load and sealing, and to see just how much penetration we could actually get out of it. Cycle 6 had the sealed packs. They were sealed on the edges, so it had to penetrate heat through the whole pack. That made it, that was probably the hardest challenge, was cycle 6 and 7 for that reason. So I want you to look at the gravity cycle, cycle 7, nothing passed. That was with the sealed pack. With the gravity, again, you're not getting that push and pull. It's just coming up. So any steam that penetrates, it's not going to be able to penetrate. What it does is going to seal off that pack with condensation, because you're not getting that push pull and that drag out of it. So with that, even on the Safe-Decon product, it still didn't penetrate that pack. And that's just to show you that the physics of having the liquids and the steam and not getting that push and pull that you would get out of a vacuum cycle, it almost becomes useless. It really does when you're running your trash. And then again, we'll get into an explanation here at the end. I just wanted to go through these testing cycles, and then I'll explain the conclusions here in a little bit. So on cycle 9, which is the last one, I didn't seal the end. What I did is I just taped it shut on the very end, so it was a little bit of a looser pack. And you'll see that was a gravity cycle 40. It had some trash in it. It had the pack in, and the only one that got through was the Safe-Decon bucket. We were able to get the kill as long as it's not sealed. The other two, it was the same way. And those bags had burst, by the way, on the gravity cycle. It also burst on the pre-vac, but about 90% of the time. But you're looking at the results, and these are a 48-hour read, by the way. They were left in there for actually longer than 48, but what you're seeing is actually a 48-hour read on these things. So, but you're seeing here that you're starting to get more and more failures. So now I want to look at cycles 10 and 11. And what I ended up doing is I changed it up just a little bit. I changed it to a 1-hour sterilization. The other one was a 40-minute. Most people do run a 1-hour testing cycle, sterilization. They just increase it, and they hope the increased time will actually increase their chances of getting the kill. Now, on cycle 10, it was a pre-vac 60, had the same amount of trash, 3-minute purge, 4 pulse preconditioning, 60-minute sterilization, 10-minute dry. We were able to get the kill on it. When I opened up the autoclave, the contents of both the wet bag and the dry bag were scattered pretty much everywhere within the autoclave. The bags were just set in there beside each other, and then the BioPro 300 was set all the way in the back, and we were able to get it. What I want to explain is, with the pre-vac cycle, it could work, but you have to know when the bag is going to burst. If it bursts at the very end, when it starts going in sterilization, you might as well just have a gravity cycle. So this is where the bag's bursting and not staying. If they burst during the first pulse, then likelihood is that's probably what happened on cycle 10. And when you see them, the bags will probably burst open, and then they're exposed to the more direct heat and steam. The gravity cycle, I moved it to an hour, and this is cycle 11. This is with an hour's worth of sterilization. That sealed bag burst along with the sealed wet bag and the sealed dry bag. Both of them had burst, and the gravity on the sealed dry, that ended up not working. They ended up getting a positive BI. So you're starting to see the inconsistency of the kills. And again, you're seeing all these failures, and it just goes on and on and on, even with an hour sterilization. The only one that was consistent was the Safe-Decon container. It was the most consistent of them all. But what this shows me is that, which is why I got exposed, is because people were not understanding the cycle. They would run the wrong cycle, and things that were in the hot side of the lab were now getting out on the cold side. And as that being your last line of defense between containment and not containment, this is where it can get very dangerous. And again, these are, labs all over the place. I see this literally everywhere. Um, I want to get into my observations and conclusions. One of the things is the pre-vac cycles, the bags, they ruptured about 90% of the time. If they were sealed up and you're trying to contain everything to put it in for whatever reason, it was they were blowing up about 90% of the time. Even when blowing up, you were still getting positive BIs. Now, the reason I put these in the pack is because getting any surface decontamination or sterilization is the easy part. It's when it becomes a challenge to where you are required to get penetration into something to make sure it's killed. And that's one of the reasons. Let me kind of back up here to something I did a while back ago. And I know most of you are having to deal with, I think it's the USDA, NIH, CDC. I'm not sure who did it, but they have a protocol now, or I forget the terminology, but they wanted everybody to show that when they autoclave their carcasses, their marine carcasses out in tissue, that they are effectively getting a kill in the process. I went to Yale and talked to them. They contacted me, and University of Florida, some of the BSL labs had consulted with me to ask about this. So I did something about it. And what I was able to do is I was able to reprogram an autoclave so that I could get data off of the inside of what the inside of the carcasses are doing and why. Because everybody was running 5-6 hour cycles and they were still getting positive BIs. So what I did is like I said, I just reprogrammed everything. And what I found out was that when liquids, because again, liquids are kind of a protector. So like with carcasses, tissue will insulate liquids. Liquids will insulate the tissue. So what I was seeing during this cycle, and it goes along even with trash, is that when you're processing carcasses or anything with tissue that has any liquids in it, they tend to protect each other. So I was watching temperatures going up and getting close to sterilization, and at the snap of your finger, it would drop 20, 25, 30 degrees Celsius, and then it would build up, and then it would protect itself again, and they would insulate. So what I was able to do was I was able to use the Safe-Decon container and a device within it so that we could take that, and as it's going through the pre-vac cycle and it's going through that squeeze, it separates the liquids from the tissue. And what I was able to do at Yale and University of Florida and a couple other places at Stanford, we're able to reduce their cycle times from they were like UF was running 5.5 hour cycles, but they were still only getting a 70% kill rate. They're now running between a 50 to 56 minute cycle, depending on the water and the autoclave, and they're getting 100% kill with. They have over I think 4,000 or 5,000 runs officially on it, and it's the same at Yale and there are several other places like Tufts that are using it, and they're using it quite successfully. So this is saving time, but they were getting a more consistent. The only reason it's more consistent, and it's the same with your trash, is when you get that liquid inside, you have to get it out. That's why the pre-vac cycle is just so critical to use. The adding of the water. I always suspected that was, for me, it never made sense. I think it actually hinders sterilization and decontamination more so than helping it. You're almost better not to do it. If you're going to seal a bag and throw it in there, there's generally enough humidity in the room. Even with air conditioning, you still have between 20-25% humidity in the room. It's still enough to even turn, if like I said, if you look at those test strips, you'll see that they still produce steam even though there wasn't in it. And almost every part of your contents are going to have some type of moisture in it. The one thing that you really want to do is avoid putting water in, and not as much. The water was it was just absolutely brutal. The pre-vac on the sealed containers, which is our Safe-Decon, it was 100% effective on the pre-vac cycle, on the 40 minute and the 60. The wet bag was 60% effective on the pre-vac cycle, and the sealed dry bag was 80%. Now factor in that the first two runs were pretty much no trash, just a piece of plastic with it strapped on there. Getting rid of those, and actually, because who runs trash with just one piece of plastic in it? It's not likely. The bags of trash that I see, the bags are full. My bags weren't even a tenth full, so there were not much trash in it, just enough to say that there was trash. The bags were very, very empty, even with the small amount of trash that was in it. With that, if you factor in having to load, they were less than 40% effective on both of them. I mean, that's not getting it done, guys. It'll get it done on the surface, but you're not getting it deep inside. So, yep. So the gravity cycle, the sealed container was 80% effective on our container, and both the wet and dry bags were 40% effective. As you can see, the pre-vac was definitely better. It should be noted that the pre-vac cycles, they did rupture about 90% of the 90% of the bags, and on the dry bags it ruptured about 60% of the time. So, yeah. So here's my my fixes and kind of final thoughts. First and foremost, one of the things that I've seen when I go around is really the lack of understanding and training when it comes to the autoclave. Everybody's just taught just to throw it in, hit the button, and let it go. Understand the autoclaves and the functions. Everywhere I went, I trained everywhere. As a technician, I walked in and I schooled everybody on their equipment, because the more they understood what it does and why it does, the more I could help them to achieve what they wanted to do. Just on a real funny note, just a couple times I would go in and I was watching someone doing a liquid cycle, and they were trying to do 5 liters of water. They they stuck a 100 milliliter flask beside it with water in it, and they stuck the load probe in that. And and I thought to myself, what are you doing? And this is the type of stuff that I ran into almost daily. And I said, you're not going to sterilize the 5 liter. And then I explained to her the physics of, go on your stove, which is going to boil first. You're never going to achieve a boiling point on. Oh, so that's why my experiments are all cattywampus and I'm getting crazy reading. Yes. And that's what I'm talking about. I've never seen anybody post SOPs at all. I go to an autoclave, there is nothing on it talking about what they should run, what are they trying to run, and what cycle they should be running it. And a lot of these cycles are put in, but nobody reviews them. Nobody's understanding that, okay, I may need to run a little bit more because I'm putting in a little bit more. A lot of this is just, again, the SOPs, it's not a difficult thing to do. Take your SOPs, post it so that they can reference it. And especially in the environment of academia, that the technicians are coming in and out all the time. And so the person you see today is not the person you're seeing tomorrow. They tend to, you tend to get a good rotation of people in and out. So this is where the SOPs really come in handy. It's going to help people to, oh, okay, this is what I should be doing. Supervision and spot checking. That's something else I rarely ever seen. It was like, yep, just put it in the bag. But then again, a lot of the supervisors, they don't know what they're doing. They had no idea or any understanding. The magic box, throw it in, press the button, everything comes out good on the other side. I can tell you that's not the truth. Adding the liquid. In this case, if you really, really, really want to add water, less is more. You just want to throw in literally a couple teaspoons or tablespoons of liquid in there at the most. You do not want to throw in 100 milliliters, and you definitely don't want to throw in 250 milliliters. The only thing you're going to end up doing is you're going to create a scenario to where the autoclave is done, the bag is burst. Now you're going to pull this stuff out, and if it's not in a container, you're going to get what could potentially be unsterilized, undecontaminated liquid down the front of somebody. It's going to be extraordinarily hot. You could scald people. Even when I was doing the testing here on the bags, I pulled it out a couple times and water went all over my feet and all over the floor, and not to mention inside the autoclave. Which brings me to another point. If the bag's burst and it's not decontaminated and you're on the clean side, you now open it up. Now you have to pick up all the contents, which are all over your autoclave. That was something that was disturbing. And I've seen this literally everywhere as well. If you're going to have anything, have some type of container, even if it's not Safe-Decon, have something that's going to contain that liquid. You don't want it just sitting in the bag. And I've seen that almost everywhere. So with that, I know I kind of went through a lot of information very quickly. I didn't want to waste too much of anybody's time for the most part, but anyways, I just want to see if anybody has any questions, anything that you'd like to know, observations, tips, testing that you'd like to see me do, an explanation of anything. So we're going to open the floor up. So Pat, go ahead.
Yes, thank you, Bob. Thank you. So yes, please, any questions, any comments, certainly, we'd love to get some input if you guys got any questions. Certainly an interesting, very, very interesting presentation about some things here, these things, certainly are true. Certainly you guys can speak to them. Even for me, just listening to you speak about the lack of of education on the autoclaves in the industry. Kind of reminds me, my mother is a teacher, and she used to tell me that we taught the curriculum to teach the kids, but we're not taught child behavior, and we don't understand how to get them to act right all the time. So anyway, okay, so amazing. Thank you, Craig. Appreciate you, brother. All right, what we got here? What about an autoclavable bag full of liquid samples, like drinkable water samples?
Yeah, you're still gonna. You can run them in an autoclave, but you have to remember. I got a bag. I want to show you something here. Now that I'm off the screen, you seal this bag and it's sealed up. You stick it in the autoclave that you see here. Now what you're doing is there's no way for the air to exchange in this. You have to heat the chamber. The heat goes around this, and plastic's a good insulator, by the way. It's a very, very good insulator. So if you're running even like a liquid cycle or something like that, you're running those samples, what happens is you're now having to heat the contents and then heat the liquids on the inside. So you're almost going to have to leave the bag open. If you leave the bag open, there is no containment whatsoever. None. You have zero containment. And if the bag bursts, you now have no containment. So if you open that autoclave, now you have to fish out the BI. Now you have to go rooting around in here for the BI. And like I said, you're it's about making the autoclave do what it needs to do. And the autoclave is not designed to penetrate bags and other things. And that's where the liquids come into play. And, Pat, this is, and most of I'm gonna pitch my product here real quick, because this is after I got exposed. Most of I tried to come up with a way to fix this problem. One, to try and speed up the process, but two, this was about safety. This was about self-preservation. And that's why I came up with this, the Safe-Decon product. This is a sealed container. It has valves, special valves on here that open up and allow the heat to come in. So once the cycle starts, it senses the heat, opens the valve. This gives you direct contact with the contents. And that's one of the reasons why I did the testing. One, I just wanted to prove the theory of the liquids, but I always throw and try to challenge this as much as possible. At the end of the cycle, this shuts back up. So if you have any liquids that you're losing or blowing up, this contains it. This is airtight, impermeable. And the reason I put that in there is just the absolute importance of, just being safe. Part of the problem is, for almost 20 years, I've been told, Bob, you're safe enough. Not that you're safe, Bob, you're safe enough. And that's what I've been hearing. And that phrase always bothered me. I always hated that phrase, Bob, it's okay. You're safe enough. There's procedures for whatever. And it's one of the reasons why I came up with this product. And that's why I'm just going to show you real quick for those that are new. These are the valves that are on the inside. I also invented a way, because everybody hates fishing out your biological indicator. So this is going to remain airtight and impermeable. This is what we call the BioPen. It just screws in. There is a self-sealing port right here that you're going to push. It seals around it. You have now injected your BI into the middle of your load. At the end of the load, the valves will shut back up, making it airtight. You're just going to pull that out, wipe it down, pull your biological indicator out, run it, and now you're going to know. Now, that's as simple as that. And what I did is in all the years that I've been doing this, I've witnessed a lot of accidents and boo-boos and everything else. One of them, one of the facilities that actually has it, they were working on some military grade stuff, and he had some beakers and flasks. He had it in there. They had liquids in it. They run their liquids in there, and he spun around, kind of a clumsy guy. His name was John. Tripped over his booty. The container went flying across the room, bounced on the floor, hit, and came back. So, yeah. But he ended up just picking it up. Broken glass everywhere. The liquid stayed contained inside. He put it in the autoclave, plugged in his load port, and then he just picked it up, put the broken glass in the broken glass bin. The liquid went into the EDS system down the drain. The end. So he didn't have to explain, didn't have to pick it up. Yeah, I see we got something from Craig. Yeah, the Safe-Decon box is actually pretty simple. If you get any burnt media on there or anything like that, it just takes a wet rag. That's all you need to do. It just wipes down. You can run it through a washer. You can just spray it down. This material is designed to not have anything stick to it. I actually took this unit and I autoclaved it with a 2-liter bottle of Coca-Cola that I got out of the store. I knew it was going to blow up. I ran it in a pre-vac cycle. I used the basket, of course, with the bag in it to help contain some of the liquids. But for the most part, it got up on the lid. I just took a wet rag and just wiped it down. So, if if Coca-Cola is going to blow up and not stick, media won't either. And most everybody is just taking a rag, and at the end they just wipe it down. But you're going to be safe because people are using the biopen, so they're sticking it in, and now they know that the load and the contents are 100%. And then the whole idea why I do this, guys, is because there's a lot of myths and faux pas. So I'm trying to run tests as things come up. Obviously I am promoting, my Safe-Decon product, but the reason I did the Safe-Decon and why I do what I do is because, I've seen the failures out there consistently. And so education is the best method for this. So, yeah, so I want to, so this is why I do it. This is to make your lives easier, safer. The process is quicker. I tried to get someone on that actually has been using it for the better part of almost a year and a half, Linda, but she was unavailable today. But what was explained to her, what was taking her 2 days to do, literally 2 days, she was actually able to process it in the Safe-Decon container in 2.5 hours. So it just, I wished I could have had her on, but she actually runs it for a living. We are getting very high praises from the people at Tufts and Yale and University of Florida and all these different places. It just simplifies everybody's life. So any other questions? Anything about the testing and the results? Yep. Hopefully you guys gleaned that, there are things, and I know that, Pat, these lab leaks and everything else, it's there's so many wives' tales and myths and everything that are out there that it just never made sense. And I'm just one of those people that's like, me, Pat, me for a while. I want to know why you do things. And then I go into discovery mode as that doesn't make sense. And then I start running my tests. So, but anyways, yeah, go ahead, Pat.
No, I was just gonna say, yeah, no, we, certainly, a lot of interesting points, a lot of interesting data. Even when I think about the inconsistencies, Safe-Decon is, our product is 100% no failure, right? And so everything else that we have in the industry fails. And even when we validate the run, and we say, hey, we don't. We can be at ease with this because we've now validated this procedure. We've seen that we're still having failures, and and there's absolutely some exposure that's happening. So so I think this is this is huge. I think this is something that if we have there hasn't been any innovation in the industry in a while, right? And we have an opportunity to standardize a procedure, do something that works consistently, 100%. Had no failures. Yep. 6, 8, probably closer to over 10,000 runs at this point. So so really excited about that. And again, so if you guys have any questions, you guys have anything that you want to reach out to us, let us be a resource for you. Feel free to reach out to Safe-Decon. The number's there. You can Google, put Safe-Decon Inc. in the in Google, and we'll come up. You can get in touch with me. You can get in touch with Bob. We can set up meetings.
Sure.
He's done a lot of work helping people, around the country. Because right now we got guesswork, guys. That's how we're operating in our facilities, dealing with anthrax, tuberculosis, so on and so forth. It's guesswork. All right. If we had a standardized way of doing this, then we wouldn't have a third party dressed up with all kinds of anti-contaminants on and everything, taking this stuff away and handling it. Right. Yeah. So let's move into a place where we have a standard, and move into a better, safer future. So
my one last thing here real quick, I keep bringing up that this thing is safe enough, but what I want to know, what I'm curious about is I always wanted to ask people how many accidental exposures are in safe enough before you're not safe. That's the question. Are we safe or are we safe enough? What does that mean? And I've been told that, and I've been thinking about this for literally the last few days. And it's like, how many exposures are there in a safe enough? And that's
Looks like
the question you need to be asking yourselves. Yeah.
sorry, no, sorry, Bob. Looks like we got one more question here, Craig. What about autoclave chemical change tape use rather than a BI?
The chemical change, you can do that, and that's basically what I used. But the problem is you're going to put the tape in, you got to fish it out. The problem with the tapes also is that if you have any liquids, you're going to get spotting, and then you're going to get false negatives on there, so, or false positives. So I don't like the tapes. I mean, they run these tapes in these tapes in the packs and everything else at the hospitals, because that actually makes sense. There's no liquids involved in it at all. But if you're in a laboratory setting and you're running anything, the test packs are just not going to do it. Your best bet is to run your BIs, period. The BI is the Bacillus spore. The spores are hardest to kill. You know, the gram negatives, mom was always right. Bobby, go wash your hands in hot soapy water and you can kill a gram negative. I mean, there's not much to it. It's the spores that are probably the most challenging. That's why there's a spore in your BI, because if you can kill the spore, you're going to kill everything. But again, the rule of thumb, 15 minutes at 250 kills almost all the spores and everything. That is your safe zone. But we're running 5.5 hour cycles to do this. The question is why? Why? You know, we're not getting the penetration. We're not getting the consistent results. That's what we need to be thinking about. Why? Why are we running 2 cycles a day when we should be running 1 hour cycles? Now everything's backing up. Yeah. And again, just real quick, I just want to show you with these bags, if you start placing bags against each other, you now have less surface area that heat can hit this thing. If you have one bag, you have 360. If you start putting another bag and you place it against this, that's almost, you lose almost about 25%. Put another bag on the other side. Now you only have 50%. You're now insulating each other. So the more bags you put in, the worse it gets. And I've seen where they stuff these bags where, you know, the surface area is only, you know, 10, 20% surface area, you know, and then they stack them on top of each other. Some of the things I've seen is and there's no way that they're getting the kill. But as everybody tells me in the industry, it's like, well, it's okay. We're just going to take it out, put it in the bin, and then have somebody else haul it off. And now it's their responsibility. Okay, what if what you're working on is a very serious, you know, version of COVID, and that truck gets into a wreck? That's another stat. I have pictures of Stericycle and all these other companies in the middle of the city where the truck is flipped over, there's been an accident, and everything's on the ground. They tend to scrub them off, but I actually have pictures of it. And then you have unprotected people walking by your waist. That's almost annoying to me. But for me, being on the clean side, trying to fix your autoclave, and then I would see that it's like, now I need to take extra precautions because these people are not doing the right thing and making sure that they're running correctly to get it out. And again, that's the difference between the hot side and the clean side. That was always very bothersome to me. But yeah.
No, this is amazing what you're telling me, because now, you know, even with today, as we move into, you know, with technology and AI and everything, we can't grow this in the industry unless we have a standard, something a foundation in which we can grow. If we're doing guesswork here in the industry, no wonder we can never get any innovation. You can't get to quadratic equations if you don't, you know 2 + 2, right? If 2 + 2 is the foundation. So
we need to be safe, not safe enough. And again, that's what it boils down to, guys. And that's understanding this. This is so critical. You know, please take to heart what I explained. I'll be more than happy to, you know, answer any questions you have. Anything, you know, you can reach out to me. Trust me, this is about your safety, your technicians, and people's lives. You know, nobody should get sick unnecessarily. I did, and it was very unnecessary. And that's what I'm about.
No, I'm sorry. Go ahead, Bob. But yeah, no, I was just Okay, yeah, no, I was just going to say, yes, please feel free to reach out to us. We're not engaging in any, and of course, we're about to let you guys go, respect you guys' time, but please feel free to reach out. You know, we're not high pressure salesmen or anything, you know, that we're hard up for anything. Bob is, you know, best in class in his field, did very well. Same, you can look me up in sales, you know, Patrick Davis, you'll see we're okay. We do this because we're actually passionate about a brighter tomorrow. And so we look forward to the conversation, further in the conversation. Bob's going to be at the symposium in Cincinnati here. Me and Bob will be there. So we hope to see some of you guys there. And we hope to further the conversations and march the industry into a brighter future for everyone.
Yep.
So again, thank you guys. Appreciate your time.
Take care. Yep.
You guys
have a
care.
great day. Bye-bye.